And let me name this example pulling the chain example. So as you can see, there is a chain lying in the form of a heap somewhere, and this chain has got some part on the floor here. Somebody is exerting a force on the free end, and that force is equal to P, and the free end is at a distance x away from that main heap. So that means that by this time a length x of the chain has been pulled, right? It means that. And that also means that maybe the links of this chain that are on the ground are sliding forward, and because of that they will be experiencing a kinetic friction in the backward direction, right? All of this is happening, and let me then give you the specifics of this particular problem. Then let's say there is a constant force. So this guy P is a constant force. Let us also say that at a certain time x length of chain has already been pulled, and let us say the free end of the chain at that moment is moving with a velocity v, which is equal to dx by dt. Now he's asking you to find out the acceleration of the moving part of the chain in terms of all these given variables. So lambda can be used, mu can be used, you can use p, you can use x, and you can use v. So the question is, that's the entire problem. Now here the statement of the problem itself makes it very clear that the main object should be the moving part of the chain, or this part of the chain here. The reason being that he's asking you the acceleration of the moving part. Now if you look at that equation which we have, the equation that we are going to use to solve this particular problem, that equation is summation of f external plus v rel dm by dt is equal to m dv by dt. You see that there is only one acceleration term, and that is this guy dv by dt, and that dv by dt is the acceleration of the main object whose mass was big M, and he's asking you the acceleration of the moving part of the chain. So it goes without any big argument that the moving part of the chain should be taken as the main object. So let us do that, and then let us try to define all these variables. So the first one that we can lay our hands on, what is that big M? So big M will be the mass of this entire portion of the chain, because I'm taking this red enclosed portion as the main object. So how much will be its mass? Mass per unit length times the total length, so lambda x. So m is equal to lambda x. Now what is the acceleration of this part, dv by dt? dv by dt, well, in fact that is the variable to be found out. Okay, cool. What are the external forces acting on this part? So external forces, you see, I will again have to choose a coordinate system. So let me take my usual coordinate system with the x-axis to the right. So this is the so-called x-axis, this is the y-axis here, and there is a force P towards the x-axis. So when I try to write the expression for F external, I'm going to get P I cap, and then there will be friction on this entire part, and because this chain is moving, there will be kinetic friction. Now in this case they have only given you mu, but if they had given you mu s and mu k, then you will have to choose mu k, because on moving objects there is always kinetic friction. So mu k times, in fact here it's only mu, so mu times the total normal reaction on this part. How much is the normal reaction on this part? Its weight. So lambda times x is its mass times g is its weight, and so this is the total frictional force, but that frictional force is in the backward direction, so negative I. So the total external force is P minus mu lambda x g I cap. This is the external force acting on this part. Okay, so external force has been done with m dv by dt. So what is vrel? Now you see vrel is the velocity of the part that is added to the main object. So which part is going to be added to the main object? This is how the system looks like right now. But a moment later, the first link would have moved forward by a small amount, and a small link here, maybe I can show it to you as a small orange circle, that small portion would be added to this chain, right? So I can say that this is the velocity of added link with respect to the ground minus velocity of moving chain or the main object with respect to the ground again. Now just before being added into the main object, into the moving chain part, what was the velocity of this link? The velocity of this link was 0. So this is 0 I cap minus, what was the velocity of this main object that was moving? So they have defined it. At time t, they are saying v is the velocity of the free end of the chain. Now the velocity of free end of the chain is also the velocity of any link, and that is also the velocity of the last link to which this small orange part is going to be added to. So minus vi cap. So you are going to get negative vi cap here. This is vrel. And what is this guy dm by dt? So dm by dt is the rate at which masses are added. How can we find that rate out? So let us say the free end of the chain right now is moving with the velocity v. So in a small time dt, by what amount will the free end move forward? v dt. So therefore its mass, small mass which is being added, is lambda times v dt, and this will give you the rate of addition of mass as dm by dt, which is lambda v. And because masses are being added into the main object, we will use this lambda v as plus. So dm by dt will be positive lambda v. And now we have all the ingredients with which to frame our equation. So let us try to frame our equation. So first, for f external, you will write this. So therefore p minus mu lambda x g I cap plus vrel minus vi cap times dm by dt. So plus lambda v is equal to m is I think lambda x times dv by dt. Done. So therefore dv by dt is, it implies that dv by dt is going to be, and you can divide every term by lambda x, so you are going to get p by lambda x, and because I have got I here and everything, I can club all these terms together and keep one I outside. So dv by dt is going to be p by lambda x here, and when lambda x they go here, they will go up with this lambda and x, so minus mu g, and then when this lambda x comes below here, lambda will go off, but you will have minus, and you will have v multiplied by v, so that's a v square, and the x will remain down, so minus v square by x, and all that I cap. So this is the acceleration. So you see that the acceleration is going to decrease as x increases. As x increases, the first term is going to decrease, then the last term is going to decrease, of course, but you see that the pulling force is p, and the total mass of the chain that is being accelerated at any moment is lambda x. So this gives you the acceleration which this part had, it would have had if it was the only part moving. But then the remaining terms, so this term shows you the deceleration because of friction. So you see the first term shows you acceleration of only this portion. If there was only this portion, then what is the acceleration that it would have had because of this force p? Then the second term shows you the deceleration that only this portion, the red encircled portion, would have had because of friction. And the third term shows you a deceleration that is present there because of some additional part coming and getting added up to this moving portion. And that's the effect of that mass which is being added, people.